Great, thank you. So, sorry. Thanks, Derek.
Good. Okay. So I have the coveted position of being the mark person between you and lunch. So we will be as brief and as thorough as we can be in that time. Uzma and myself work for Ontario Teachers Pension Plan. What does that mean? So we're the largest single profession pension plan in Canada. We have over 190 billion in assets. It's a very fancy way of saying we have one customer, and there's a lot of them, and we represent all of their retirement assets. So we have 1,200 employees between Toronto, Hong Kong, and London that manage the fund and all of our customer requests. So we work for the Member Services Division, which basically takes all the requests from all of our clients, and we deal with all of the partners, all the school boards of Ontario, and we automate all of that using workflow. So everything that comes in our organization, the interdepartmental transfers and handoffs, that's all done through workflow. And so we have a long history with workflow. Started back in the 90s with case management, which is basically digital file folders moving from department to department. We automated that in the early 2000s. So departments now didn't need to know where the folder went next, where the air conditions happened, who was handling what. They did their job, pushed a button, and it went somewhere else. So we brought in BPMN-powered workflow, which worked quite well. It did exactly that. It moved stuff from place to place, and that was it. It was a queuing system. It automated stuff for us, but we had to build a lot of infrastructure around that. Web Server Process Server came in the late 2000s. We migrated to that as a natural progression from MQ Workflow. When that was retired, we were looking for something else. We employed Sandy. I don't know if Sandy's here anymore. There she is. Sandy came and helped us assess what did we need, what did our business need, what did our developers need, and find the right tool. In 2013, we brought in Camunda, so we've been using it for about 6 years now. We've got a lot of experience with it, a very extensive development team that works exclusively with our workflow environment, so Camunda and all of the assets around that. And it's been running our workflow for many years. So our processes, we have 144 templates. A lot of them are parent processes, but there's a lot of reused sub-processes. So things that happen often in certain departments that are used in every single process we have, controls, audit, approvals, those kinds of things we shell out into a sub-process so we can reuse those, deploy new versions of those, and do late binding on those. So that works really well for us. We run about 70,000 processes per year in our Member Services Division, and we have at any point in time 20,000 active processes in flight between different departments. Our work patterns vary. So our clients can initiate processes from their web portals. So both the school boards and the teachers themselves can log in, make a request, initiate. Sometimes it's a vanilla, goes in and out, and they get the response right away. All goes through our workflow engine. Other times you have batch calculations. So when people turn a certain age, that month we send out a bunch of letters to them. That's all flown through our batch calculation engine, which runs through Camunda. We also have events and schedules. So processes themselves will schedule a later date. I've done my thing. In 6 months, I want to wake up and do something else. That'll schedule a future process. And that can happen up to 10,000 at a time. So certain points during the year where we have fiscal responsibilities, we will spin up 10,000 processes and fire those out the door. And so Camunda manages all of that for us. Our design principles, our teams work on a pull model. So we will have 20,000 processes within our Member Services Division, and different teams will be focused on different processes, but it's up to them to choose the work they want to work on. We don't use email as a delivery mechanism, we've got a work list. And so they pull their work from their work list based on their skill set, what they want to work on, their time, and even the time of year. So the interesting thing for them is they need to know what is valuable to the business at that point in time. So we have, on top of Camunda, we have a prioritization scheme, which tells them what the business values. Okay, it's Friday, we've got to get this stuff done by the end of the week, so these things will bubble up to the top. When Monday comes around, those kinds of things will be lower priority, or at certain times of the year, things bubble up. So prioritization for us is really key to the pull model. So it's like a JIRA backlog for our developers. They know what's next, they know what's most important, and there's stuff that's over here. So if you want to go find it, you want to work on something, you can go find someone else's case, pull it forward, because it's related to the one you're working on. So for spousal stuff, you can pull that in, but you know what the most important stuff is. We have a lot of long-running, multi-department processes. So data comes in our organization, it bounces from one department to another. There's approvals, there's finance, there's things that go out, there's regulatory. So those departments need to work all together. And a lot of times there's external dependencies. So we're waiting for data from the client, a response from another financial organization, another pension plan. So we don't have control over when that's going to come back in. In a pull model, that is challenging because you've got something in your inbox and you can't do anything about it, can't make it go away. We've had to handle that in different ways, so I'll get to that in the next slide. We have a lot of loopbacks, so a lot of financial regulatory requirements, and so they need to get seen or risk analyzed on the way out the door. So if it's not okay to go out, it needs to go back to either the department that sourced it, the originator, or somebody else who can fix it or adjust it so that it can be improved. So we've got a lot of loopbacks in our processes. That's just a design requirement we have. The long-running processes mean we have multiple BMN templates. So we do version control on all of our templates, and we have at any point in time 2 or 3 versions out in production because processes will last 6 to 9 months or a year. We might have a couple of versions at any point in time. So we make a decision, and using actually some of the Camunda tooling, which is really, really great. The Camunda versioning system shows us whether we can upgrade or whether we have to manage 2 versions at the same time. So that's really helpful for our developers. If they find a bug, it's okay, well, I've got 20,000 processes already using this template. Do I need to upgrade? Can I upgrade? Or do I need to let them run out? Because they've already gone past that point. So that helps us out quite a bit. The versioning piece, that was a big win for us. The ability to snooze long-running processes is something we built for our clients. So they've got an entry of 10,000 processes, and 5,000 of them are waiting for another client or another financial organization. They don't want to see those, they want those to go away. So they can push a snooze button on it, and it makes it go away. So we have a couple different models for that. Our original one was this. So our department here could say, you know what, I've called the client, they need to send me some piece of information, I just got to wait for them. So they'll put it into this suspend state. Basically, we had a suspend user as a department that just held all of this stuff. The challenge with this worked very, very well. It was very effective for our clients. They loved it. Stuff that they didn't worry about went away. Made the processes really complex. So there's this task, that's the actual task. Then there's this, there's a decision point, and some other timers and stuff that had to go into that process. And every single human task had to have that capability. It was very messy. Original design had that all the way back into MP workflow. That worked okay, but made the process very messy. Our more up-to-date design, we built a shadow process. So this process allows us to tag an existing running process as suspended. So we start up this process, it's our suspend process. It goes and tags that process and says, hey, you're sleeping. So that tells all of our systems, that's not active, don't show that to anyone. It's got 2 ways, it's got a timer, so they say, I want us to go away for a month. After a month, I'm going to call them back and say, okay, you really need to give me this document. So it's a timer on it, but also if the document comes in, an event happens, that'll actually unpen the process and it wakes back up and it goes directly to the department that's working on it. So that goes along with the pull model, being able to make stuff go away and make it come back. And some of the capabilities of BPM2 and the way Camunda works very well for us. It's a good fit. Our workflow architecture, so Camunda is at the center and we have a lot of stuff around the outside, largely because we're tightly integrated with our business and our CRM tools. So I'll talk through a couple of those things. Our workflow interface service, that's basically our front door. That's how all of our clients get into our service. Camunda's got a very rich interface, but we have some business logic on top of that. So that's how all of our Angular apps and all of our other mobile apps and components get into our service. It also translates some business domain stuff into workflow and hides the workflow implementation from our business, so our abstractions don't leak out. We have a workflow intermediary. That was built a long time ago when we had NQ. Its job was to basically hide the workflow engine from our clients. We didn't bind too tightly to our workflow engine. That's lasted quite a while. Actually, our colleague Fred over there built that many, many years ago. And it handles all of our runtime process concerns. So all of the active process in our organization, that's its job, it's the front door for that. It was also our primary point of federation. At one point, we had 3 workflow engines running, sometimes the exact same process in different templates and different models, and our business did not know. They had no idea we were doing a multi-year migration through 3 different workflow engines. And intermediary hid that from them. So that was actually really effective at doing that. So like Sandy said, no big bangs. This is a 3-year not big bang process, which is very effective. And it does process prioritization, so all that calculation of what priority happens, how the priority works in our organization, that happens in there. And it does some caching. Obviously with all that calculation, doing that on top in real time is challenging. So we cache a lot of that stuff on the fly. So our workflow archive, this is basically our elephant. It remembers everything about every process we've ever had. Largely for regulatory reasons, we've got to track everything we've ever done. And so this is effectively a giant listener. It listens to all the Camunda events, coming out, and it actually filters for us. So Camunda throws a lot of events, very, very verbose, which is great for debugging. It is not great for audit and regulatory. There's a lot of stuff in there. So we can capture only the events that we care about, and this is the history. So we can go back 20 years in the past and see who started what, when was it passed off, who signed off on it, and all that kind of stuff. That's our record there. Camunda will keep all that, but there's a lot of information there, so we can pare a lot of that down. So it optimizes those kind of logs for us. We have Camunda External Task Service. This is how Camunda talks to our services. So it makes a lot of calls to our business services to make risk decisions and get business logic back. It uses the long polling pattern, which has been very effective for us. So we used to manage all these queues, fire something onto a queue, handle it all internally. Now Camunda does all that. So Camunda manages all the queues. All sets does is pull stuff off the queue, and it fires it to our core service and puts it back on. It captures all the business errors and sends those back to Camunda. That's a very thin layer for us, but gives us a good way of centralizing all of our talking points out to the core services. So our workflow environment, just to give you a sense of what kind of team manages this. So we're a Java Spring Boot REST shop. That's where we start everything. So when we're looking for tools, we naturally look for things that fit into our environment, things that are lightweight, will fit into our automated CI pipeline. We strive for automated regression on everything. All of our services, all of our UIs, they're fully automated and integrated into our CI pipeline. They don't get deployed to development unless they pass the tests. So we want tools that fit into that model. Microservices is our main deployment model. Sandy was talking about, we've gone from the monolith into microservices. We're not fully all the way there yet, probably 80–90%, but that fits into our model quite well. And we've got a customized end user interface. So we do have that bespoke application that our customers use. So we integrate Camunda into that, so they see their business data, they see their process, and they see everything else for the customer all in one spot. So to them, it's all related. So what we were looking for when we selected a workflow engine, ease of deployment. So we want all of our devs, we've got 5 devs all working on different processes. We want them to be able to work locally. So something that's lightweight, easily deployed locally, moved around quickly from staging to prod. Testability of flows, so the ability to unit test different parts of the flow. You've got a 37-step flow, and you want to test at step 36. I don't want to have to do 35 steps to get there. I want to start it up and say, I want to test this part of the flow, so easily unit testable. That was a big win for us. Transparency of implementation, so we are an open source shop. I want to see what's going on in the frameworks that I'm talking to. So if there's a bug, and we can throw a breakpoint in there, or go down and see some verbose logging, we're comfortable doing that. Rich API and ease of error handling. So the rich API for us, the REST API, that's a big win because we can bind it to anything we want to. So we've got our interface in front of it, our analytics engines use it, we can use it for our data warehousing and stuff like that. It pulls everything we need out of that API. We don't need to go into the database for anything, we don't need to bind to the database itself. And migration of in-flight processes, that was a huge win for us because we used to spend time trying to push stuff through our business. If we needed a new version out there, okay, we've got 10,000 of these, let's see if we can push those through because we want a new version out. Now we can run multiple versions, or we can migrate from version 1 to version 2, and even version 3 before a single process finishes. In some cases, the process will start and it'll go through 3 versions before it actually completes. So that was a big win for us. So I'm the hand-wavy guy. I'm going to pass you off to Uzma, who's part of our development team. And she works with Camunda day in, day out, hands-on.
All right. Thank you. Thanks, Derek. And this is Uzma. I've been told there is another Uzma Khan in the audience today. Hi, what are the chances? First name and last name. Anyway, so I'm going to be talking to you about some of our development and automated test practices and how all of that is culminated into a fully functional CI/CD pipeline. We have been using this CI/CD pipeline for about a year. And as Derek mentioned, one of our main motivations to come over to something like Camunda was the ease of testability and ease of deployment. So Camunda allows us that via its Spring Bootable applications, which runs Camunda engine in memory. So you can work and collaborate on process design. You can test it locally, much like a Java application, using JUnit test libraries. In addition to Camunda's Spring Boot application, we're also using the external extensions like the Camunda BPM-powered and some of the other assertion libraries which help us assert as we are moving from task to task. So locally, when we're doing development, we're working on the BPMN we are able to test all of these changes in our local environment, so all of the developers are working together. While we are doing our unit testing, so Derek also talked about how we have a complex environment where processes are multi-layers deep, starting from a parent process and then a child process and then other child process. As we are moving through all of those, we want to assert on different tasks. If the flow control is working as we expected it to work, also we want to assert on some of the task variables which are set on some of the user tasks, as Joe was just showing, right? So also, one of the motivation of doing unit testing is that we want to cover as many business scenarios as possible in the component level, because that is less costly. So we drill down most of our business scenarios on the unit level testing. So once we are, so yeah, this shows us the coverage of one of the unit tests. This is also a library provided by Camunda, so we're using that heavily. This is a test report generated after running a unit test, and it's showing you for one of our processes what path the process took in that scenario. Once we are done our unit testing, we are ready to deploy to our development environment, and the process has graduated to the dev stage. At that point, process is running on the dev instance of Camunda Engine. We can browse it through the cockpit. We can see multiple versions of it. We can integrate at that point to the rest of our workflow environment, like for intermediary and archive. So at this stage, we're able to test our integrations with the rest of the system. One of the very beneficial layers that Derek just mentioned was the facade, the front door for all of our clients, the facade layer that we have built on top of intermediary and archive and the Camunda REST API. So what that allows us to do is to model interactions just like clients would interact with a workflow process, right? So we wanted to move from one task to another. We will call a REST API on Camunda to complete a user task or complete an external task, and we'll do that via our external API so that we can do the translation from the business logic to Camunda language. So in this way, we are able to test processes from start to finish. We are also integrated to the other components of the architecture, and this is what the coverage looks like at this stage. This is the screenshot from Camunda Cockpit that the process took the various steps, and this was an actual instance running. This was not the local in-memory engine. This was running in development. So one interesting challenge we found, we discovered when we were working on the end-to-end testing stage of our process was related to the processes which have external task callouts. So not all of the processes have that. Some of the processes have these external task callouts which call out to the business logic, the web services, the microservices which encapsulate the business logic. So the challenge here was that the development environment is also used by our testing department and training department to work on some of the processes that we are using for training, right? So if our Camunda external task service, which is the worker listening for all of the external callouts, or all of the external work that is being given by the process to the core services, if that was running all the time, the processes that the training or the testing had set up would get eaten and move forward while they wanted them to be in a certain state. So we did not want that to be an issue, so we decided in our development environment to turn the workers off. So in that case, to move the process along, how do you do that? Because if the worker is not on, the token is always going to sit there at the external task. So Camunda REST API again to our rescue, and we actually force complete or auto-complete those tasks. So I skipped the slide too early. We auto-complete those tasks programmatically, and that way we can move the process along. And that's how we obtain end-to-end coverage on the process. So once we did that, there was a concern that there's a gap there in terms of full end-to-end testing. If you think about it, we're not actually exercising the external tasks. So there was a concern that there's a gap there. In order to get around that issue, we came up with another technique, and we thought that what if we just locally start the Camunda external task service and also locally start another version of the process which only has the external task callout. So the rest of the process is kind of taken away. There is just a test process which only has that task exactly as it would be in a real process. So in this way, we are able to test the mappings, the input and output variables that are going into the external task and coming out of the external task. So we are able to test that contract, and it also allowed us to debug certain situations, especially if we have some test-only process variables which would not be in a process instance in a real situation. So that was a tool that we kind of developed during our processes, during our testing practices. And last but not least, so we do our unit testing, we do integration and end-to-end testing, and then we are finally getting ready to release to prod. We do one complex, one interesting scenario with everything turned on, from user interface to command external task service and everything in between, and we test that scenario end-to-end, completely interactively. And our testing department helps us with that, and when we get that sign-off, we release to prod. So that was for the pipeline. So as we were working on these tools, well, as we were working through the tests, because we're going through a migration phase from our older platform to newer Java stack, so we are doing some heavy test development these days. We also, so during the process, we discovered new ways of doing things, right? And that gave rise to, that helped us create some interesting tools. So one of the layers that we've talked about is the side that we have built as the front door to all of our workflow architecture is a Spring Boot REST service. So what came out of it was it's Swagger API documentation without much cost, right? So we can use that API documentation to execute some APIs, and in this case, what's interesting for us is to complete user tasks and to complete external tasks, which in the testing environment we do it programmatically, but when testers are working on it or we're debugging something, sometimes you want to push the process forward without going through the UI, so this allows us the ability to do that manually. So this was an automatic win from doing what we were doing, right? So that was one of the tools. Another tool that was invented by one of our developers here was, we call it Workflow Process Viewer. So the challenge that exposed the need of something like this was one, that our process environment is pretty complex. We have over 100 processes, and they are in multiple layers. They're parent, and they can go 6 or 7 layer deep. So in that environment, when we're working on unit tests, and you wanted to go from one task to another task, analyzing different flow conditions, it was really hard to keep track of all the BPMNs open using just the modeler. And every BPMN is a separate microservice. It has a separate repository. So every time we'll be working on a process, we'll be like, okay, now we have to clone this repo, open it in the modeler, work with all of them together. So how we can make this analysis easier? So that was one challenge. The other challenge was that we also wanted to analyze the impact of change as we are developing these test patterns. We wanted to be able to see if we are touching a sub-process, let's say 3 levels down, what will be the impact of this change, how much regression needs to run on this so that we can gain confidence that we haven't broken anything critical to the business. So I'll just quickly show you what that looks like. All right, so this is what it looks like, and you can look at the cheerful face. Who developed it? It's right there. And the face gets more cheerful as I search for my favorite process. I hope you can notice that. Right? So, all right. So this is a process that we were working heavily on in the beginning part of this year. As you can see, this is a fairly complex process. One thing that was really interesting about that was that this is called by almost 25 parent processes. So there was no easy way to see that without something like this, and communicate it to the business, communicate it to all the stakeholders involved, that what would be the impact of change on something like this, right? So developing this tool really helped us visualize that. Another visualization for this was this tree diagram, which is really just another visual representation of what I just showed you. So on the left side are all the parent processes of calculate entitlement, and then on the right side there are other sub-processes that this process calls. So it communicates very clearly what environment is this process sitting in, right? So I talked about when we were developing unit tests, we wanted to, so you can imagine if you're writing a unit test for calc entitlement and you are driving it through a parent process, how complicated that can get. And you have to walk through all these tasks depending on all of these flow conditions. So it was really hard to work with just a modeler. So with something like this, like a toggle button here, we were able to see all the flow conditions that drive all of these paths going from one stage to another. Also, because we're asserting on task IDs, in the unit test at least, we were, by implementing something like this, we were able to quickly see what tasks are involved in this process, and this really helps us during code reviews, during discussions with the testers or business experts, that is, if what we're testing for is making sense. Something else, another feature of the tool, we have some script tasks here, so sometimes they're changing variables, they're formatting them, or they're clearing data or setting data, and we want to watch out for that for testing purposes. So again, if we're just using the tools that are out of the box, it was getting a little bit complex, so we worked. Another really cool feature of this tool was that you can just click through the sub-processes as well. It's taking a little time to render, but I think you get the idea. So I'm going to move ahead from the demo. All right. So in addition to the tools, but we also wanted to talk about the reporting, monitoring, and alerting side of things, because that's also really important to get a real picture of what's happening when we actually deploy the process to prod, how many processes are working, how many have incidents, how many have failures, so that we can debug and troubleshoot, right? So two pieces that we are collecting statistics on right now is Camunda itself and the Camunda External Task Service, because that's our new piece in the architecture, and we really want to closely monitor it. So in order to do that, we are collecting statistics from Camunda. We are feeding it through a Prometheus exporter. We are also doing that from our Camunda External Task Service and feeding it to our alert manager architecture, so that we can visualize the data on dashboards, right? So some of the examples, a couple of examples that I'm going to show you are, for example, the queue depth. So we talked about how we used to do it all by ourselves before, but now Camunda does it for us. We don't have to do any queue management. So inside Camunda, we have implemented a few workers, and this screenshot is showing us that currently the queue depth, for example, for 871 log is 0, for 865 generate letter is 1, for that one over there is 9, so there are 9 tasks waiting for a worker to be picked up for that process. So that's that diagram. And other interesting screenshot is for, so this one was Camunda. This is Camunda External Task Service metrics. So on the top left, what we're showing here is really hard to see is that how many tasks are started and finished by a particular topic, so by a particular queue. So the upward bars are showing us how many tasks were started, and the downward bars are showing how many are completed. So this picture is really good. It's like equal, tasks finished and are equal to the tasks started. That picture over there is showing us how much time it took Camunda External Task Service to finish a certain task. There are no errors right now in this screenshot, and it's also telling us how many tasks were corrected if there were any errors. So there's a feature when you're using the long polling pattern that you can set the retries. If the task fails, that will automatically be retried until it reaches a certain threshold, so that picture talks to that. So there were some errors, but they were automatically corrected. Last but not least, lessons learned through all the multi-year migration, and also the migration for the other development and testing practices coming off of our previous stack to a Java-based stack. So one thing that we learned was that embedded logic and flows complicates testing. For example, here I'm showing you that on a user task, we have a listener, which is a Java class embedded into, which is part of this process, but it's in a separate project, and there's some code there which is doing something to some variables here. So we have to watch out for what is happening in the listener. So that just complicates testing. So that was just a lesson learned, that if we could minimize that, that would have really helped us. On a similar note, we also have some Groovy tasks, the script tasks sitting here. And their purpose is almost the same. They're either formatting data, because our UI, which has predated Camunda and has lived as the front end as we have gone through 3 different workflow systems, it expects data in a certain way, right? So as an artifact of that, we have tasks which take care of mapping certain formats. They sometimes clear some things, they sometimes set some things, so we have to watch out for that as well. So that was something that we learned during this process. One other thing that Derek was talking about was the long-running processes. We also learned that because we were going from different technologies, sometimes it was easier to let the older versions complete their lifespan, because it involved a lot of analysis if you wanted to upgrade to the newer version right away. And maintenance of long-living processes also gave birth to another pattern, which is that we decided that, okay, if a process is running for example, several years, and I think there are longer running processes, about 6-7 years, we decided that it's probably better to split it up into sequential blocks, like stages. So the one process will finish its first stage, and then we know that it has to wake up next year in April, so we will schedule it, and that also gave and that's how we ended up creating another piece in the architecture called process scheduler. So the process knows, the process doesn't know it calls a core service that would know what is the next process to schedule, and it will talk to the scheduler to schedule it. And when that happens, that instance will come up in Camunda. So that was my last lesson learned, and that's it. If you have any questions.
You mentioned very quickly something that complicates the process. I think it was 3 slides before. So you said I'm going to put too much business logic in that's in one step of the result set. It complicates it. So how would you do that differently in simplify?
Well, so for example here, we are just formatting some of the process variables that are running through the process lifespan. Ideally, we wouldn't need to do that, but we are doing that because there are other pieces in the architecture. For example, our front-facing, like the user-facing UI, it expects the data in a certain way. There's a certain language that was developed when we are working with other workflow systems. So we kind of have to maintain that, because if we roll out that change from process level, then everything in our environment will have to change right away, and we can't really do that because we're working on it.
This clarification, that is my gut. But how would you, okay, is there a way with Camunda that you could flip that or simplify it?
For anything significantly complex, we'll externalize it into a call-out to an external service. Or this use case, you can use a script task where you've vet it all. You can actually also call to a Java class. Those Java classes can be completely unit tested outside of having to specifically run the process to make sure that you're getting all the use cases. So burying stuff in a script task is very convenient and quick and easy when you're doing mock-ups. But for long-running processes to get regression testing, it's challenging, because now you've got to run through the whole process to get that coverage.
You have an extensive experience in that course. Now, during the those years, did you have to spend a lot of time tweaking the internal configuration, especially with the external tasks, number of threads for this or that? Or did you use just the vanilla configuration provided?
For the most part, I worked out of the box. I mean, we try to stay as vanilla as possible with our integration with the system. The REST API that was our go-to for anything we need to do with the process. It provided us with enough flexibility that we didn't need to go in and customize anything specifically. Things like retries and stuff like that, that's all configurable. So we did a lot of that based on the process and what kind of life cycle it had. We would configure some of those things, but everything, all the knobs we needed were already there.
Long-term process
Yes.
you talked about. Did you want to do some customization of the management state or some that was done based on certified version customary processes? Did you use the capability of now your
It's got the token sitting where it's supposed to be, and so we can do restarts, we can do redeploys. All that keeps track of itself. So everything's persisted in the database. So even Camunda upgrades, we do full upgrades, and everything comes back up, and it knows exactly where it's supposed to be.
Okay. Yeah, okay. That's great. Thank you guys very, very much.